Hey guys, welcome back. Mr. Marone here. Welcome into our first video of Chapter 8, hopefully the shortest video that you will see all year, because it's on Pythagorean Theorem, something that you guys spent so much time on in middle school. Just a reminder, Pythagorean Theorem is only used in right triangles, and it's only used when we're trying to find a missing side. So I've got my picture here with sides A, B, and C, and they're lowercase. And just as a reminder, the theorem is a squared plus b squared equals c squared. That if I square all three sides, the two legs that make up my right triangle or my right angle, if I add those together, once they're squared, they're going to be the same thing as our hypotenuse squared. Okay, and most of the time, you're going to end up with some sort of a radical form here, and that's where we have these two options of rounding to the nearest tenth or leaving in simplest radical form. So if you see leave in simplest radical form, you're going to have to simplify the radical. And we're going to get a lot of practice with that over the course of this section, just like you did with similarity a little bit. The other thing that's kind of nice that we're hoping for is when we have Pythagorean triples. And those are three sides, all whole numbers, that satisfy our Pythagorean theorem. So one example of that, if I just change colors here quick, one example of that would be the 3, 4, 5 right triangle. So if I have 3 and 4 as my legs and 5 as my hypotenuse, if I did 3 squared plus 4 squared, and look and compare if it equals to 5 squared, I've got 9 and 16 equal to 25, and 25 equals 25. So that works. So that's a Pythagorean triple. There are pairs of them. Anytime you multiply the same number by all three, like if I did 6, 8, and 10, that one would also work as a Pythagorean triple, and so on and so forth. So we're rooting for Pythagorean triples, but it's not always the case. One thing that kind of shoots off of this, one thing that we can use that's a little bit newer, is if I use Pythagorean theorem, if I'm given three side lengths, let's just say I'm given 4, 7, and 10. So that makes up a triangle, and I want to know whether the triangle is acute, right, or obtuse. They haven't given us any angles, but we can use Pythagorean theorem to make sure we know what is the correct answer of acute, right, or obtuse. So if I do the Pythagorean theorem, I do 4 squared plus 7 squared, and I'm not sure what it's going to equal, but I'm going to set it equal to 10 squared, and just work my math out. I've got 16 plus 49, and I've got 100 on this side. 16 plus 49 is going to give me 65, and I have 100 on the right. So in this circle here, 100 is clearly bigger than 65. If our hypotenuse side is bigger than the two legs, we have an obtuse triangle. So that's what you see on that left-hand side. If c squared is bigger than a squared plus b squared, it's obtuse. If our two legs ended up being bigger when they were combined than our third side, we have an acute triangle. And if they're equal, it's a right triangle. So it's just a little thing here, but it makes a big difference. We're able to determine what type of triangle we have without having to do any math in regards to the angles. So hopefully this gives you a good little refresher. I didn't want to spend too much time on it because Pythagorean theorem you've seen over and over and over again. So I wanted to make sure we hit it, but didn't spend too much time with it. If you have any questions, be sure to ask in class, and I will see you guys then. Have a great day.